we go, Algebra 2, Unit 6, Lesson 1. We're going to be talking about the nth roots and using rational exponents. So you can extend the concept of a square root to other types of roots. For example, 2 is a cubed root of 8 because 2 to the third equals 8. So in general, if we have an integer, we'll call it n, which is greater than 1. So something like b to the n equals a. Then b is an nth root of a. So again, depending on what our exponent is going to determine what type of cube it is. And so we can write nth roots of a like this, where n is the index of the radical. So again, this is like inside of our square root sign. We can also write them as like powers. So just a couple quick examples. So if I have a to the 1/2, and then that is squared. Again, what I do with my exponents is I multiply my exponents. So this is like saying 1/2 times 2, which is going to cancel out. And I'm just left with a. Very similar. Again, I could have a to the 1/3 power. If I cubed it, 1/3 times 3, it's going to be 3 over 3. 3 divided by 3 is 1. I'm left with the same thing. So if we look like what we have here, if n is an integer that is greater than 1, and a is some real number, if n is less than 0, you have no real nth roots. If a equals 0, you have one real root, which is 0. And if a is greater than 0, you have two real nth roots, which you can find right here. And again, this is if it's an even integer, and then we have the same set of rules if we have an odd integer. I'll just rewrite these bottom two, kind of got hard to see, I guess. So this one is the cubed root of n equals a 1 over n. This one is the cubed root of n to the 0 equals 0. And the cubed root of n of a equals a to the 1 over n. So being able to convert it how we did right here is going to be super important, and we will get some practice doing that. So here's an example. Let's see here. Find the indicated real nth roots of a. So let's say that n equals 3 and a equals negative 216. Well, because n equals 3 is odd and a is negative number, and so that means a is less than 0. So I'm looking at this top one, has one real nth root. And so I'm going to say, okay, because negative 6 to the third power equals negative 216, we could write the cubed root of negative 216 equals negative 6, or we could also write it as negative 216 to the 1/3 power, which equals negative 6. One more example. If n equals 4 and a equals 81, n is 4 is even, and 81 is greater than 0, so that we know that we're going to have two real fourth roots. So if I think about this problem, because I can do 3 to the 4th equals 81, and negative 3 to the 4th equals 81, we can write our answer as plus or minus the fourth root of 81 equals positive or negative 3. So again, positive 3, negative 3, that's going to be our answer. Excuse me. Just reminding ourselves about these exponent rules. So this is going to be, again, a big one. How can we convert from one form to the other so that we can calculate this problem out? And then notice that this one is a negative. And so remember, negative exponents move your answer into the denominator. All right, so I'm going to solve this next example two different ways. Let's say evaluate this expression, 16 to the 3/2. So I'm going to rewrite it in rational form, rational exponent form, and I'm going to write it in radical form. So 16, 3/2 equals the square root of 16 to the 1/2 times 3. 16 to the 1/2 is the square root of 16, which is 4. So I'm left with 4 to the 3rd, which equals 64. If I look at it from a radical perspective, I have 16 over 3/2. Again, this is what I'm going to use right here. So notice where n goes, where m goes, and where a goes. I'm going to translate that into, again, if I put this 2 here, it doesn't mean it. That's just a normal square root. So again, the square root of 16 is 4, and I'm left with 4 to the 3rds, which equals 64. So again, I basically just used this property right here to help me rewrite it. One more example of those. Let's say that we take 32 to the negative 3/2 equals 1 over 32 to the, to the 3/5. So that's equal to 1 over 32 to the 1/5 to the 3rd power. So what number to the 5th power equals 32? Well, that's only 2. 2 is the only answer that's going to work for that. So we get an answer of 1 to the 8th. Kind of went over the line there, but that's okay. Let's do it the radical way. So again, 32 negative 3/5. Going to use this property this time to manipulate my data. So negative exponent, put it down below. Then I'm going to bring this denominator, and that's going to be my cubed root, my index. And then I'm going to put it on exponents outside here. Again, the cubed root of 32 is 2. Oh, forgot that it is all under 1. 2 to the 3rd equals 1/8. Last example. Solving equations. Let's say that we have 4x to the 5th equals 128. First step is to get rid of this 4. So again, anything I do on the left, I'm going to do on the right. Divide by 4. X to the 5th equals 32. Now I'm going to take the cubed, or the 5th root of x, the 5th root of 32. We just did an example like this. X equals 2. If I have a slightly different problem, maybe something like x minus 3 to the 4th equals 21. Again, how do I undo this? First step is to take the 4th root of everything on the left and everything on the right. So all I'm left with is x minus 3 equals the 4th root of 21. And that's going to give me a positive and a negative answer. So I'm going to add 3 on both sides. So I'm left with x equals positive 4th root of 21 plus 3 and negative 4th root of 21 plus 3. So those are my two answers, which if you calculate it out, it's approximately 5.14 and 0.86. So depending on how the question is phrased, it may say keep your answer in radical form, or it may say round to 2 decimal places.